You can see the
Yes.
presentation, right?
Yeah, exactly. We
Okay,
can.
perfect.
I can.
Where
Yeah,
to see it?
it's visible.
Okay, live. Okay.
Yeah, just click on that. I think that should be fine. All right. Okay, guys. Thanks a lot again for joining the meetup. I'm very excited about today's topic because it's also aligned with my personal interests. So the agenda for today is after my introductory presentation, which will be very quick. I'll just hand over to Atmaraj, who will be presenting today's topic, and after that we'll have a quick question and answer session, and we can also have Q&A amongst within the presentation whilst Atmaraj is sharing his presentation. Depends on how he wants to go with it, of course. And after that we'll have a quick accountability share. So some of us are doing our projects, and if you want to share your status and your progress with the projects, you can share here. And if you are looking for some accountability partners, you can also talk about that after that. And at the end we will have introductions and casual networking, where we'll get to know each other in a more casual way. So the way we generally learn is we focus on robotics and artificial intelligence, and we do weekly meetups and we do monthly research paper discussions. So far, seven. This is the seventh weekly meetup, and we have already conducted one research paper discussion. And for project accountability, there are actually two possibilities. So one is that you could share during the meetup itself after the main discussion, or you could also check the channels on the Discord server and find accountability partners, even by casual communication in the chat room. And the meetup for today, as with every meetup, will be recorded and shared on YouTube, so that people can have access to it and refer to it even after the meetup is over. And since not everyone is able to attend.
Chandandeep,
Yeah.
just a second. Sorry for interruption. One of the guy wants to join, and he, I guess, already joined it, but he's not able to enter into the meeting. So could you let him allow?
uh, what's his name?
It's Samir TJ.
Samir TJ. um, okay, I can give him access right now, but maybe you can ask him to uh, write his introductions in the introduction section, because that's like the formal process of getting access.
Okay.
So I'll continue with the presentation. You can meanwhile help him join it, right?
Mm-hmm.
Okay, all right. Yeah, so we are a volunteer driven community, and as today Atmaraj has volunteered to explain his project case study, so also you can also volunteer and share your project, or even some computer vision, deep learning, or NLP concepts if you are into that. But the main thing is that these meetups actually depend on your participation. So the more volunteers that we have, the better it will go. So I highly encourage your participation and volunteering for these meetups and research paper discussions. So now I'll just pass to Atmaraj, where he'll be explaining the whole project. And today we'll also have the chance to see the live demonstration in simulation. So it would be pretty interesting. So over to you, Atmaraj.
Yeah, once again, thanks, man.
Thanks for volunteering.
Yes, no problem. One
Yeah.
moment.
Meanwhile, Mudit, did your friend join already?
Yeah, he said that now it's visible for him to Enter the meeting. Yeah, he is in meeting right now.
Okay.
Yeah.
Yeah, okay.
All right.
Okay, start.
Okay. I'm going to try to share my screen. I just share my whole screen. You see my screen?
Yeah.
Okay.
Yes.
So I don't know why is the formatting like this.
The font changed.
That's
Yeah,
fine. Yeah.
on Google, maybe you can download
I don't
it.
know. Chandandeep gave me the file actually in.
So
Hello
maybe
everyone. I'm Atmaraj Gopal. I'm studying in the Reutlingen University. It's
uh,
near Stuttgart. It is,
sorry, Atmaraj.
yeah.
Just I think the reason is because you're opening it in Google Slides.
Yeah. That's also true.
But I guess
Maybe I
you're on.
can download it.
Uh, I think that it would be similar on the Ubuntu. Uh,
Yeah, because I don't have the fonts, right?
yeah.
It's pretty
But
ugly.
anyway, yeah. Let's continue.
I think we can manage, right?
We
I
There's
can
think
a
we
manage.
have.
Yeah.
PowerPoint online also if you just download it and yeah, it doesn't matter. No matter.
Yeah, it's too late for that. Anyway, I'm Atmaraj Gopal. I want to show a simulation. It's a project that I'm working on. I have been working on. And for those of you, how many of you actually know Move It? It's probably bad to ask like this. We can't really put up our hands. But if you know ROS, and you worked with industrial robots or collaborative robots, you know about the Move It package. It's a motion library package that has, maybe I shouldn't jump too early. Let me just start like this. Okay. So the problem that we are discussing today is the bin picking problem. I think in Meetup 3, we discussed this theoretically and try to brainstorm some solutions.
Atmara, I think I can
Yes,
share the screen and you can just tell me when to go next. I think that would be better.
let's see how many slides are really damaged.
Some slides seem fine, but
Yeah,
I guess I can share the screen. I can share the
okay,
screen.
do the honors. I will stop my share
Yeah.
from here. The bin picking problem is something we have discussed about in Meetup 3, where everyone brainstormed some solution. Chandandeep presented the system, what are the required stuff. So today my aim is to show the progress and also the problems that I have. And we will be doing it via a simulation demo. And this pipeline, grasping pipeline that I have addresses the bin picking problem. And it uses deep learning as a tool to generate grasp poses. So if we have objects, how do we select how to grasp it best? And we can maybe present basic concepts, but let's see if we have the time today. For the demo, so next slide, please. So the bin picking problem, just to remind, is we have a random pile of objects. So we have different objects of various geometry, various textures, various weights, and we have a 7DOF robot manipulator. So usually 6 degree of freedom addresses most of the problem, but we have one redundant degree of freedom, which allows a more we have various solution for one problem, for one pose problem, for one inverse kinematics problem. So the task is to pick objects one by one. And guys, if you don't understand, if I'm going too fast, please just interrupt and clarify. We can clarify it on the spot. I like things a bit more dynamic like that. And yes, so the requirements for the robot, we need to find the a proper grasp poses for each object. And since there are various objects, like how do we determine which is the best grasp pose? And then from there, we need to be able to determine the size of the object. That means we have to isolate the objects from the environment and then determine the size, and then we have to know the jaw opening. So and next will be grasping forces. So if we are going to try to grasp an egg, we don't apply too much force, and we have to also recognize if the grasp was successful. So this kind of feedback is required. These are the requirements. I can't say today's demo will fulfill everything, but at least the robust grasp poses is what we should be able to see. Next. I think we need to skip this. Can we continue?
So here, I think, yeah, depending on how you want to structure it, we could have a
Mm-hmm.
discussion where we could talk about some solutions, or if you want to skip that and do
Mm-hmm,
that
mm-hmm.
later, I can change to the
I think we
next
can
slide.
skip that and do later.
Okay.
Yes. So the system is roughly made out of this. We have one RGBD camera. So D stands for depth. RGB, I guess you know. Depth means we estimate the distance of each pixel to the camera reference frame. And this is done by, because you have stereo cameras and also an infrared projection. And we have a robot manipulator. So in our case today, we have a 7DOF, 7 degree of freedom robot manipulator from Rethink Robotics that we see in simulation, and a gripper. So this is a robotic gripper, but we have a similar parallel jaw gripper in our simulation. And we have the bin. Okay, software setup, ROS, definitely, as usual. But within ROS, we're going to talk about the simulation environment. We have Gazebo, and we have Move It. So the Move It motion planning library, and these are two subcomponents of ROS. I will send you description if you are interested, links to the package. And today, the deep learning system that I'm using here in this solution is GPD. It's an open source package by Art and Pass. He's from Boston University. And in the newest version of Move It, there is a module called Move It Deep Grasp. It's also integrated into Move It. But when I started doing this last year, it was not integrated yet. So I feel like a pioneer, but actually I'm not. It's grasp post detection. It's a CNN network trained on the big bird point cloud data set. It's not really point cloud, it's RGB and depth images data set based from real sensors. So since the data set is based on real sensors and not purely simulation, it's pretty good representative of the real world sensors, you know. Okay, next. Okay, we come to simulation. Okay, now all hell breaks loose. Thank you, Chanandip. I'll try to take over.
Yeah. So I stopped sharing now.
Is everything okay so far? Like, I don't know if I'm being clear at all, and
Yeah.
it's structured.
Yeah, everything is fine.
Thank
I
you.
think this is just the introduction. So main
Yeah.
thing would just start now.
Let's go live. So what you're looking at is actually Team Viewer. It's connected to my other PC because it's when you use simulation, it takes a lot of processing power, and everything's all hell breaks loose when I open Discord and browser and everything. So let me start by showing you the simulation itself. Simulation is dead. 1 second, guys. Is it dead? Yeah, the GUI has died. I think that is fine. Let me do a quick sanity test real quick. If closed. So I had a gazebo GUI. It showed the environment where we have the object and the, probably we do need that. Can I restart things real quick?
Yeah, sure, sure.
Yes. Okay, let me just save this configuration so we don't lose it. Of course, nothing works when you want it to, right?
Yeah, we have the backup stuff, right, for
And in
those.
German, they call it Vorführ effect. So whenever you're trying to present something,
Yeah.
it doesn't work. So what we
That's the
have
story of
here,
our life.
What's the effect
Uh,
called?
I like how everyone chimes in.
for us engineers, that's the story for our life.
Everyone can
Chill.
What was
relate.
the name of that effect?
Vorführ effect. So it's a German word,
Uh-huh.
Vorfuhr. That means presenting. So whenever you're presenting, nothing works.
Okay. Yeah.
Yeah. So all our professors just know that this happens. They just accept it as a fact. It's amazing. All right. Can you see it? Okay. So this is our world.
For people like me who
Yeah.
have no idea about ROS, could you also explain sort of what's going on in the background?
Yeah. Definitely. Definitely. So
Thanks.
we are
Thanks.
just beginning.
Yeah, yeah.
So thank you. So what I did here is I just launched the simulation. So it's called Gazebo. It's the simulation environment. So there are some people use Unities. There are many other simulators, VREP and such. It has a new name now. I don't remember. So in case I don't have access to a real robot now, this is called like offline programming. So you have a simulated robot where all the joints are represented, joint limits are the same, and you can add some objects. And also the sensors, we have two camera sensors. One is mounted on the wrist. Here it seems floating because we don't have the complete URDF, but on the real robot that I have at the university, it's actually a different gripper. But we can set the transform, so the position of the camera link relative to the end effector, and this should be representative of your real robot. And I have another camera here. So these are two RGBD cameras, and for two different users. We'll see why real soon. And these are some objects that I added to the scene that we'll try to grasp and hopefully not destroy. Okay, that is the gazebo. Now,
Sorry. When you
yes, sorry.
said, should I ask doubts now or later?
Yes, no, please do, please do. Ask.
You said there's supposed to be a transform between the camera and the end effector, between the camera that's placed
Yep,
on the end effector itself, right?
yes.
Okay, so but it's a small transform. Like I'm assuming from the camera to the end effector is just a few inches away.
Yeah, a few centimeters, the
Okay,
X, Y, and
okay,
Z and RPY.
okay, cool.
But then I
Thanks.
have one from the head as well. This is the head link.
Where's the other camera?
It's here, floating here. Can you see my mouse?
I think your mouse is
Ah,
not
it's
moving.
laggy.
I guess you are not the gazebo window is not open. I guess it's only the other one.
No, I guess
I
you're
can't.
just not
No.
seeing my mouse actually. This
Yeah,
is
your
Yeah,
the
we can't
mouse.
see the gazebo screen.
No, we can see
ah
This is
the
not the
simulation is the gazebo screen, right?
I guess the camera is that gray box kind of thing, right?
yeah. So
Yeah,
everyone does
yeah.
Yeah.
see the robot, right?
I
This is
think
Yeah,
gazebo.
your
yeah.
yeah your mouse is probably, I don't know, sometimes
Yeah,
not moving, but I think we can see the gazebo screen, right? I can see at
yeah. I
least.
think I'm not
Yeah,
visualizing the mouse that I'm.
yeah. The gazebo screen is visible, just the mouse is not.
okay, okay,
This way
okay.
I have to enable this somewhere. I'm so sorry. Let me try to find this.
But I think now it seems to be fine somehow. I don't know.
No, that's the mouse. This is the mouse I'm using now.
Mm-hmm.
Ah, okay.
I have to try to show my mouse. Hmm, Okay, this is allowing deny.
टीवी भी वैसे कर रही है
But it's
नहीं नहीं
fine. Maybe you
नहीं
can just zoom to that place. So I
Actually, I
Yeah.
guess.
can use it here.
but the
Can you see
mouse
my
is
mouse?
visible actually we can see the mouse
Yeah, we have two different mouse. I have another on the main PC, and we are just looking at another PC from here. Anyway, I can
okay
use this as well. This should be better.
okay fine yeah
Yeah.
Okay, so
Now
this
it
is the
seems good.
mouse.
Yeah.
This is another camera. Sorry,
Okay.
okay yeah.
Thanks.
and
Yeah.
here is another camera mounted.
Mm-hmm.
And this is the Rethink Robotics, one of the first collaborative robots that came with elastic joints. It's a noisy robot, but
Mm-hmm.
so the camera has a y transformation only in the y direction right it's only has a height from the base
yeah, yeah,
your 000 is near the bottom of the joint
yeah.
okay
So it
yeah
depends on the orientation of the robot. It's of the original frame of this end effector link.
Mhm.
Yeah, then depend on that whether you have X, Y, and Z also, or rotation. Like in my case, I needed to add a yaw rotation, 90 degrees.
Mhm.
But that's always, robot dependent. Okay, so let me start. Now I can't do anything with this environment. Of course, I can add objects and everything, but to actually control the robot, I'm going to start the move it package, and Arvis is the only the viewer. Let it load. No, it's taking so long.
What's the name of the robot that you mentioned?
It's Sawyer, Sawyer,
Okay.
from Rethink Robotics.
Mhm.
Why is it?
Oh, you are working at Rethink?
No, no, no. I'm just using the robot. Our lab had the robot. Rethink went bankrupt and then was bought over by this German company as well. Just some general info there.
I think it crashed.
No, no, it's loading.
I think Rethink is still working, right? The company is still there.
Yeah, it went bankrupt and then it was bought over by, not bankrupt, I don't know. They wanted to sell the company. It was bought over by Han Automation, Hans Group, HAHN Group.
Yeah,
That's
Han Robotics. Now they changed the name to Neura Robotics.
no, no, no. That's a different
Neura
Hans
is, I think, a separate
robot.
company itself.
Yeah. So you're talking about Hans robot. That's where I work.
Okay.
Um, Hans Robot Germany. So
Ah,
this is the, but there's
in
HAHN. That's a German company. Han Group. They all have the same
yeah.
name.
But weren't you working at Neura Robotics? I think you mentioned that last time, right?
Yeah. So Neuro Robotics is the new rebrand name of Hans Robot Germany.
Ah,
That's a
okay.
Chinese company. I mean, it got Chinese investment. It's a German company, and now it rebranded into Neuro Robotics.
Okay.
But Rethink Robotics was bought over by Hans Group, like HAHN. The early one was HAN apostrophe S. I mean, why are we going through this? We can discuss this later,
Yeah,
yes?
yeah, yeah.
um, okay, now what I want to do, we can run the Python script. Oh, I can show you what data is here. So this is just a GUI that shows the robot and its sensor information. Um, let's see if this works.
So what are the green voxels on the RV's map?
Yeah, those are the occupancy grid. Those are the voxels that, as you can see here, we have one cloud. Yes, this is one point cloud. It's pointing into nothing, and this is probably the wrist camera. But also we have another camera. Let me just disable the viewing a bit. See, everything is laggy. Oh my god.
Uh, Hi, Atmaram.
Yes.
Hi. So thing is, I wanted to ask, how did you, uh, just a
Sorry, I lost you. Hello. Did we lose him? I don't hear him.
I think yeah, we lost him. I
Oh,
think
that's so suspenseful.
yeah, the internet
So we
could
have,
be.
yeah, sorry. So we have two camera stream. So one of the camera stream is looking at the robot. So this the head camera is looking. You can see my arm. You can see there's some points on the arm. If I take off the robot, move it. Yeah. So this is one camera stream from the head, and we have another camera stream it's this view angle. If I turn this off, oh, okay. This is the other camera. Yeah. Right. The thing is, I'm using this camera stream to generate occupancy maps. And what's very interesting is I've used the OctoMap package. It's integrated into MoveIt. Occupancy maps means it shows you which points are obstacles. Like for now, we don't want to collide with the table, so the table is considered an obstacle, and so we just don't want to collide with anything. It generates yeah, them as voxels to show that, like, you can relate if you deal with mobile robotics. It also shows which are the walls, right? Those are all occupancy maps, but this is a 3D occupancy map. So if I turn back on and we look at the geometry, okay, one second. It's not very good for a demo, but you can see.
Hi.
Yes, sorry, we lost you.
Question is, this grid of pixels, this green boxes.
I can't hear you.
Akshay,
For
your internet's I think a bit choppy, so I
I
guess we
think
can't
you,
hear you
I
clearly.
think you can write in the chat room probably if because we
Right,
can't
bro.
understand you.
Yeah. So what's interesting about this package is it's using the camera stream from the head, but you see it filters out the robot arm. See, these blue points are actually what the camera sees. It it doesn't generate any voxels for the robot itself, but it generates for everything else. So it has a self filter based on the robot's description, and this I found very interesting. This is important because you don't want to detect your own arm as an obstacle. Okay, these are the basics of what we want to talk. So if I want to grasp something, let's just start here. I have a script here that will run. I'll explain what happens here. Mm, so this is a Python script that will launch my robot and then my gripper. Okay, we are in simulation, and it goes to the initial pose. So I have a breakpoint here, so we'll stop here and see what happens. And if everything somehow works, we should see it go to its init post, unless it's already at the init post. It's going to initial position. So this is the plan. Yeah, it's probably, I know why.
I think uh,
I
the
removed the
point
point cloud.
cloud, yeah.
Yeah, it makes things very laggy.
So this point cloud is from the mounted fixed camera, right?
Yes.
The one in the green that we're able to see right now.
Mm-hmm.
Okay.
Everything fail again. Oh shit. I have to do a quick change. So I worked with the real robot yesterday using the same script, and this is why everything is a bit mixed up. And Chandradeep, I mentioned, right?
Yeah,
Having moved it here, it's really taxing.
yeah, but that's
And
fine. I mean,
yeah,
the goal is just that we understand the whole pipeline,
yeah.
right?
Okay, I can you through the pipeline while it's actually
Maybe
refreshes.
you can explain while it's loading. So
Mm-hmm. So this is the main script. We can ignore the on top. So first I go to the init state, and then I start the loop for detection. You can restart this also. Let it go to the proper init state. And then what I do is I start, what is this? Oh my God. See, nothing works when you're trying to present. Nothing works. I literally ran this before we started. Okay. And then I open the gripper. Of course, we don't want to do any motion with the gripper closed. So I open the gripper, and then I go to the detect pose. The detect pose is when I could see the images, the objects in my point cloud from this camera, the one in front. Yeah, okay, let's let it complete the motion. Let me remove the gold state. Okay, it's much better. So this is the init state. And now we'll go to the detect pose because we want to see the objects itself. In detect pose, like we can barely see the object in this camera. So it should move. Please move.
I think
Is
that's
it
fine
moving?
even if it does not uh, work
Mhm.
properly. I mean,
Yeah, okay, it's taking some time. Usually it goes fast. I'll tell you why it's taking some time. So what are these green voxels? These green voxels means these are obstacles which we don't want to collide, which means it's doing a calculation of its path considering all these voxels, you know. So takes a lot of time for planning to make sure you don't hit any of these voxels. It's a lot of
Atmaraj,
processing power. Yes.
I guess you could just close the gazebo part. Maybe that might speed it up a little bit.
The GUI, right? Gazebo still
Yeah, the
runs in the
GUI of the
background.
gazebo. Yeah,
Let's
if you
see.
close the GUI, it should probably speed it up. The
yeah,
RVS
Yeah,
part should speed up at least.
yeah, that's a good
yes,
observation.
it's
Yeah.
good tip. Um,
Also, I had a very small question.
yes.
Uh, what's the reasoning behind using the secondary camera that is attached to the
Yes,
gripper?
correct. So this
I
is
mean,
what we
what
thought
would
before.
sorry
Yeah.
to interrupt, but what I would like if I was doing something similar, I would consider attaching the RGBD camera to the gripper itself,
Yes. So
considering
I
I want
had
to do precise gripping and such kind of actions.
You're completely right. We are on the same page on this because we do have one gripper here. You see,
Yes,
these are two different camera streams. This is what I
yes.
tried to explain earlier. If my thing wasn't as laggy, we should see another camera stream here. And this is where you can see the robot points, you know. These are from the other camera, which is on the head. If not this camera, I think.
Okay, got it.
So I do have two cameras. One of it I'm using to generate voxels. Another one I'm using it for grasping. So now let's say I want to grasp this beer can.
Sorry, just once again, just one small thing. Are
Yeah,
both the cameras RGBD or is it just one camera that is attached to the that's the stationary camera that's RGBD?
they're both RGBD.
Oh, okay. Sorry. Okay, got it,
Yes.
got it.
No, nothing to be sorry about. I'm sorry for
I
it
was
being
under
so
the
laggy.
impression that it was just one camera that was RGBD.
Hmm. That mustn't have been clear before. So now we have a problem. Now, if I want to grasp this beer can, it's going to fail because this is a collision. So we have to exclude the collision. But for now, let's go through the script. What I'm going to do now, if I'm going to step through, we're going to call the set parameters for grasping. What it's saying is I set my bounding box, like I'm saying this is my workspace.
Hmm.
Consider only points that are within the workspace. That means all my objects are within the workspace, and I'm also setting the approach direction. So if I want to grasp from on top, I can filter the grasps that I generate to be, from this direction, from on top. Or I could also set, okay, I want to approach from the X direction, and this is what GPD does. The network just gives me, I'll remove the workspace because it's blocking a lot. I remove only the visualization. The workspace is actually still there. Um, I want to generate graphs from the top direction. So let's just call the generate, this is the interesting part, the deep learning part. We call it deep learning, see how fast it goes. I want to generate graph poses. it failed. I don't know why. Let's try again. It could be because my server is died for some reason. Oh my god, I have all kinds of errors here. Actually, let's not waste time like this. I'll tell you what should happen.
Yeah.
So I generate grass poses here. I want it to work at least once. And then from the grass poses, I can get multiple candidates. I can get like 5 candidates. So I have all my grass poses here. Let's say 5 of them. And then I cycle through them. I try to reach each of them. So in my first attempt, let's continue. It might fail again, but we don't know. Of course, it will fail again. The service died. So in my first attempt, I just want it to work. You know what? Let me restart this. Meanwhile, we can look at the some
Can
interesting.
I suggest something?
Yes.
Instead of debugging, first maybe
Yep.
you could directly run the program and it does. Like it was pretty cool to see the robot even going back to its initializing position. So
Mm-hmm.
maybe uh, because we are
Just
in a
let it run.
demo, it would be cool to see a thing being grasped if that's
That's also
possible.
right. Yes. Let's try to do that.
So it's okay if the debugging doesn't happen. Maybe
Mm-hmm.
if everyone's okay.
No, I just restarted the service because the grasp detection service died.
Mm-hmm.
And now let's see if it works. I can just let it run. Not very happy with this. So my initial plan was to have the gazebo simulation running separately on another machine and use ROS to connect, and that would be very snappy. But that solution didn't work um, in the short time that I had. The movie hasn't loaded. I
Yeah,
would suggest
meanwhile, I
what
guess
it
you
loaded.
can
Yeah.
just share the presentation. I
Yeah.
think that gives the concept like in a
Oh
very
my God.
good way.
Yes, you're right. So OctoMap generates obstacles. So we generates a plan around the obstacles. Yes. This is what or I think I don't want to cover OctoMap so much. I would rather cover what GPD does. So earlier, before this, on Meetup 3, we talked about grasp detection using DexNet. DexNet is another deep learning based solution that it generates
Actually, we
grasp
didn't.
based.
Sorry, actually, we didn't cover. I mean, I just briefly mentioned it, but yeah.
Okay. Yeah, so I did a comparison and we selected GPD in the end. So what it does so well compared to any other thing, it generates graphs only based on geometry. So sometimes you can tell, okay, if the object is cylindrical, just grab it in the middle. You can teach that, or grab it from on top. You can teach this, and there are many solutions that do this, trying to do some template matching. But what this does is it generates normal from each point. It does some normal calculations. There are many ways from each point in the point cloud, and from the normals, it generates lots of candidates. You can see a lot of like unreasonable grasps, and some of them are reasonable, and then it filters it based on approach direction and also the score. So these candidates are input into a network which then filters and generates scores. So the green um, grasp is the grasp with the best score, and the others are the with lower scores.
Hmm.
And this is just what GPT does within the network. Whenever I do this detect grasp and how it's trained, I think we'll fix. So one of the main thing that it does so well is filtering the grasp. So we have so many candidates, and I filter the grasp in the X direction, in the Y direction, and in the Z direction. So from on top. And this is good because usually the robot has limited freedom. You don't want to um, you want to do like top down grasp. It will work really well with DexNet. It's only trained for top down. It's only trained from top to down, but here you have many options because it's based on the point cloud. So usually from when you have a mesh like this, like a clutter, it generates different grasp poses from the object, and from this cluster, the one with the best grasp will be selected, and then consequently that's the bin picking solution. Um, let's see if our thing is already alive by then. This okay. Another short thing I want to add. So earlier we saw this OctoMap, right? So what if it considers all the objects that I want to grasp as collision
Voxels.
objects? Exactly. So that means I can't directly grasp this because it always tries to avoid plan around this. So everything will fail. So what you do, Move it has a neat solution that it attaches an object there and filters out the voxels only around this part. And there are a lot in the Move it demo. This is what my pipeline does. And then you can grasp the object while avoiding this object, avoiding the all the objects on the table. Otherwise, if I turn off these voxels, it would grasp this object, but it might come from under and hit the table. And if like someone suggested earlier, I'll just let script run. Meanwhile, it's booted up.
So the order of pick is determined by the GDP package based on the norms that it developed and obstacles that it may encounter.
Yeah. There are
Also,
a lot of way we can filter it. For now, I'm just cycling through, attempting all the generated grasp poses. But eventually, I can also. Where's it going? It's going to init pose. Then it's going to detect pose back.
Atmaras, what is the
Yes.
input to the network?
The input to network is just the point cloud. Point cloud,
Point.
and for the GPT package is also the workspace and the direction of grasp.
Okay, so you give the point cloud, and then the output which you get are the like a vector of the poses, object poses.
Yeah, correct. They are each of the poses have different scores.
So it means like the number of poses you get would be similar to the number of objects it detects in
No,
that point cloud, or how exactly?
not really. So if I give an point cloud of only one object,
Yeah.
it will generate several candidates for this one object, right?
Okay, so it could happen that you might get so m to n kind of mapping. So if you have
Correct.
m objects, so multiple poses for each, and
Yeah,
so you
correct.
know that there is also like information in that it's telling object one with three poses, something like this. So you'll have that in the output of the network.
Yeah. So it doesn't know what object, when it generates a
Okay, yeah.
graph pose, it doesn't know if it's one object or two object. Sometimes you can grasp two objects at once. It just tries to generate grasp. This kind of
Okay, okay. So it doesn't
isolation.
segment. Okay,
Yeah.
okay. It doesn't
Like,
segment the object.
yeah.
Uh,
So this is one proposal that to integrate inside this is we do some sort of point cloud clustering, or we filter the point cloud with a mask from um, object detection solution. So it gives you a mask. Okay, this is Apple,
Mhm.
and filters out everything else, and we filter the point cloud from that and input only the Apple point cloud into the GPT package, and then it generates grasp poses only for this. And now we know whenever I grasp anything from this grasp poses, it's going to be an apple.
But then
So
you can have collisions in that case, because if you are filtering out one object and still there will be a neighboring object on the side,
you
in
are
that
right.
case, if that would be leading to collisions,
Exactly.
right?
Exactly.
Yeah,
That's why we have two cameras, because the other
yeah,
camera is the one that generates the OctoMap.
yeah.
hmm.
Right.
So,
So
but
now, like, you are
initially,
completely on track. You completely get what I was trying to present, and
Okay.
move
so
it is
but
not collaborating.
so I have one question. So
Yes.
initially we feed the whole point cloud to the GPD, and we do the filtering, the segmentation of the objects only after that, right?
Um, no, you could do
Or
it before as
initially.
well.
So in this pipeline, you also do segmentation of the point cloud before you feed it, so the objects are separated, or that's also, or is it just another approach that you were mentioning?
hmm This is an approach that I have tried before, but I did this object without collision avoidance. So that worked perfectly. So I did segmentation. I select an object. I select a cluster of points, which there is a package called rail segmentation. It does you
Mm-hmm.
it uses the PCL library, the point cloud library, to do Euclidean segmentation using the k nearest neighbor algorithm. It just detects a cluster of object. So I could use that, or I could also use um, any of the available object detection like YOLO or something. This is what we used before. YOLO tells me the apple are these pixels. These are apple pixels in the scene,
Hmm.
and I create a mask out of it. I filter my point cloud, and then I generate grasp.
Okay.
This is also another solution. But
I mean, interesting would be if you detect multiple objects separately and then merge it together into one
yeah,
piece
it's
of,
all possible. It's all possible.
yeah, that would be like kind of a very
Exactly.
safe kind of thing.
What I'm doing now that's causing a lot of failures is this OctoMap. So we have
Yeah.
this demo from Move It. I'll just maybe I can open. Oh, this is the wrong browser. I'll change the machine. So let's see. Move It. Object. Oh no. So there's the planning sync tutorials. This is also the older one. Anyway. Oh my god. Mhm. So here's there's a pick and place tutorial where it works. So this they're doing, but not in simulation even. This they just attach object um, in the scene, in the RV scene. So these are not even simulated with real physical properties and all that. But what is the question? Whether we can do collision
May I
avoidance?
also ask, in your
Yeah.
simulation and in this one, there's a transparent robot that moves before as if it calculated that this is what I want to do,
That's
and
the
then it.
plan. Yeah, I'm just visualizing the plan.
Ah, okay.
Yeah, that's nothing much. I don't know. Mm, let me look at the. Oh my god, this is not working, guys. We need to come back again for this. Let's see. Um, that's time. Okay.
Uh,
Let's.
Atmaraaj?
I'm just trying to find an overview of the complete pipeline.
Atmaraj?
Yes.
Yeah, maybe what you could do is just explain the whole thing, like why the PPTs, and maybe make a small video demo kind of thing if it doesn't work out for today.
Yeah, you are right.
Like we do want to see the thing working
Mm-hmm.
out for sure.
Wait, I have one demo somewhere. You are right. I think this is just the GPD. Okay, can you give me like few minutes that I can find? I made another demo video without collision avoidance actually, but it generates the grasp poses and you can see. Let me find that. It's on my phone. I'll transfer it here. Chandandeep, can you take over for give me
Yeah,
three
sure, sure,
minutes?
sure.
Sure.
Yeah,
Take your
sure,
time.
sure, no problem, no
All
problem.
right. Okay, I'll just turn off screen share for a while. Um, you can continue with the slides, because on my Google slide it doesn't look good.
Okay, let me see.
I have the videos.
I guess I can just share your slide and we can talk
Yeah.
about
Yes.
this thing.
Please
And
do that.
yeah, I mean, but
Please
I
do that.
guess we would come back to you for doubts, I guess, because
Definitely.
yeah.
Here, I just need to transfer my video.
Okay, so I've shared the screen now. This is the presentation that Atmaraj was sharing. And so here, yeah, the pipeline that he talked about, basically having the point cloud and then after that segmenting it, choosing segments, grasp pose detection, and then picking. Yeah, I think this makes sense, right? This is
Yes.
clear for all of us. And graspability score for calculated grasp candidates. Okay, grasp pose, failure handling, midpoint of segmented cloud. Okay. Um, yeah, I don't know what RT Lions PC map.
Oh, so RT Lions is our RoboCup team. We developed
Okay.
also a grasp detection. So what we did is we detected cluster in the point cloud. So and then what we did is from this segmented cloud, we created a bounding box and we got the midpoint of the cloud. And we say, okay, go grasp the middle. And the
Yeah.
middle is not ideal to grasp everything, but this was our first version of I don't know, some solution.
Okay. This was the
It was
initial
good.
version.
Yeah.
Yeah.
Yeah. So this is what we did. So we had a segment of each object. You can see each color
Hmm.
is one object. It did really nicely, these clusters.
But was it
And
actually also this accurate? Like here it looks almost perfect.
that's how good you can get if you set your, because this you can set statically. What is your minimum number of points that constitutes a cluster and your maximum number.
Hmm.
That
Hmm,
way,
hmm.
it also has a surface removal. So we have a model of a surface and it removes all your table points. So
Okay. Yeah.
it requires a lot of configuration to get it really nicely.
Hmm, hmm, hmm.
But then if I get the middle of the hammer, it might still work. Um, but if I'm looking from on top,
Hmm.
also the middle works a lot of time, but these are very ideal objects. But for many objects, it won't work. And also you must remember, like this is a simulated camera image, but the segmentation is real.
Ah, yeah. Okay.
Simulated
Hmm.
camera is always very clean, but actually you have a lot of waves, a lot of
Hmm, hmm,
noise
hmm. Yeah.
included.
Yeah, that's why it's so good. It's on simulation. Yeah, then it's about DexNet, which is not the point of today's discussion. I think actually we can cover DexNet as well in probably one of the research paper
Yeah, actually,
discussions
which
sometime.
you are right.
Yeah.
That will make things clear, like what's the state of the art
Hmm.
at the moment. Okay, 1 second. Still looking for the link.
Yeah, you can, I think, focus on that. I'll
Yes.
just, uh,
Yes.
click through the slides and we can talk
Mm-hmm.
about, yeah, we can just talk about
Yeah.
it and get back to you after that.
Mm-hmm.
So yeah, I think slide was also clear. I think so. Getting normals from each of the points in the point cloud and then generating different grasp candidates by feeding it to the model, having filters and selecting the one with the highest score.
Yeah.
If
And there are many
anyone,
types of filters as well that we can use. So one thing is every graph pose it generates, but we have no information about the position of the robot.
Mhm.
You don't know whether you can actually reach these graph poses. So one way is to uh, kinematically, I know, try to plan to each of these poses and see whether you can actually reach it. before actually executing. And that way you can also filter again what are reachable graphs or not.
Okay. Hmm.
But then if you have like OctoMap, that will take planning very long. So to do anything in real time, it will be terrible.
Yeah. So basically, after calculating the grass pose, you also take the OctoMap into account, and then the Move It package does its role of having a trajectory, right? This is how it works.
Mm-hmm. Yes, for now.
Hey, hi.
Yes.
Finally, I'm able to hear you. I'm sorry, guys.
Oh,
So,
great.
I have this question. So, how did you created this point cloud?
You use depth camera, RGBD camera, like real sense is usually.
So, if I want to say, can I say it like this? That you are basically creating a meter to pixel mapping?
Definitely. Like this is not really a 3D view. This is, they call it a 2.5 D view. So we project, we estimate the map, the depth at each pixel, and from that we generate a point cloud together with your RGB.
Okay, and is your occupancy grid same extension of your point cloud?
Yes. So the point cloud, we downsample it. So voxelization is just downsampling it. Once you downsample it, you can fix a box. You know, you can downsample it. Let's say on every centimeter you have one point. After downsampling it, you can create a box at each point, and then what OctoMap is this package that puts all your voxels into a graph. It's, well, it's a octree graph. There's the other presentation that has octree graph. So what this octree graph is, let's say you pick one voxel and you say all your nearby voxels are like your branches, and each consecutive voxel has their branches, and this way you can um, codify, you can encode your whole voxel really small. You can make it like a really small file, and also you can test for collisions really easily. It makes it really fast. So this is the OctoMap package. It's OctoMap. This is what Movit does as standard.
Okay, so and this OctoMap, the is it restricted to RGBD camera, or can I extend it to any kind of sensor which can create a 3D map?
Any kind of sensor, like you can use also a LiDAR and use OctoMap for for mobile navigation.
Okay, okay. Thank you, thank you. Thanks a lot.
But of course, you have to see whether it makes sense to use OctoMap for whatever use case for
Yes,
you,
yes,
right?
yes, exactly. Yes, that's there.
Hmm.
Yeah, I think we can give you some time to actually downloading the stuff that you're looking
Yes,
for. Yeah.
yes, I have the file. I uploaded on my Google Drive. Trying to find it.
Yeah. I think this is the OctoMap presentation. So I'll just scroll through it. Let's see what we have here. This is voxel representation here. Okay, I think these are like details of how we define octree. I don't know much about this.
I'm not seeing this. Yeah, they're actually videos. I don't know why after I send them.
Actually, I mean, if you don't
Uh,
find it right now, it's fine. You can also like do it later, right? You can do it during the week, and that would be fine.
yeah, I can also upload it. Oh wait, I found it. Nice. I finally
Oh,
found it.
great.
Good timing, bro. It's also a live demo.
I guess the images in
Okay, now I
this
just have this.
presentation are also quite good for explanation, right? But yeah, of course, if you found the video, then that's always better.
Yeah, they're actually videos. Like all these things, they're videos or GIFs. Somehow after I load it, it can't play in Google Slides. And of course,
Okay.
I'm using Ubuntu. I can't play it after downloading it as well. So if you have Windows, maybe you can try.
Yeah,
But
maybe you can
this
send it
just
to me.
filling the time. I get it. I'm so sorry, guys. I do respect your time.
No worries. So the should I stop streaming now? Do you want to share?
Yeah, I'm just finding it on my PC. It's in my WhatsApp group. Like we have the RoboCup. Okay. Yes, I found it. It's downloading real quick. Sorry, but you can share. I'll take over now.
Okay, perfect.
Screen. Let's say screens. Go live. Ah, nice. Okay. Oops. So, do you guys see my screen? Hello? Hello?
Uh,
Yeah, yeah.
Yeah. Yeah.
Good. So let me prime you. So this is the script running on top, and here we have the real live camera stream. It's on VLC, and this is what the camera on the arm actually sees.
actually, I'm not able to see the recording. Is it
Yeah,
visible
your
right now?
video suddenly stopped.
Ah, that's not good. We see. I don't get it. Why must it all just
No,
be like this?
actually, sometimes it's a problem with Discord. It sometimes stops. So it happened with me last time as well.
Okay.
Probably you should restart whoever
Mm-hmm.
because I can see his mouth uh, moving. Yeah, but now yes,
Okay.
Do you see it now?
I guess the problem is viewers
Yeah,
end.
it's visible. I
Yeah.
can
Okay.
see it.
Finally.
Okay.
Do you see
Mm,
the video? It's playing now.
actually, I can't
Yes.
still see.
Yeah, same.
Okay.
Oh my god! I'll
It's
send you the
visible to
video
me.
in
We're in
the group.
2021 and having such problems.
Yeah, shit happens, man. Like, of course, when I
Yeah,
want to show some.
it always happens when it shouldn't, basically. Yeah, yeah. I think best would be if you can share it with me, then I can share my screen, I
Yes,
guess.
maybe everything I do just doesn't work. Okay, let me get
No,
you.
I guess it's I don't know what the reason is.
I the Discord's problem. Sometimes it lags.
Hmm. Yeah.
Maybe you can upload it on one of the file sharing services and then provide the link with,
Yeah,
yeah,
that's what I have
so
to
that
do because
everyone
it's too
can
big.
go there on
It's too big for
probably. Oh, okay,
Discord.
it's too big.
It's too big for Discord.
Yeah, yeah, not for Discord. Maybe you have it
Yeah,
on
I'm loading it
Yeah.
on
Google Drive
my
or
Google Drive.
yeah.
Okay. I guess meanwhile we can do the introductions.
Yes, please
Yeah,
do.
while he's uploading the video.
Mine is
So
uploaded pretty fast.
let's start with Aditya first. Like very briefly, if you can introduce yourself.
Hello, people. So, my name's Aditya, and I'm currently living in Baroda in India. And I'm presently preparing for my master's in robotics in UNSW in Australia. And so, presently, I'm living at home and studying, like preparing for the master's and doing some small project work here and there related to robotics and electronics kind of thing.
Mhm.
Yeah.
Nice.
And
Welcome,
great to
Shapey.
be here.
Welcome.
Yeah, that's me. Right.
Meanwhile, I've sent the video link. Okay,
Okay.
continue.
Okay. Yeah. Akshay,
It's
can you
yeah.
introduce yourself? I think Akshay also has some network issues, right?
Yeah, I think Akshay is traveling or something, and we
Yeah.
heard like some.
Okay. Info Subhas is, I think this is the first time you're joining, right? Can you introduce yourself?
Can you give some info about Subhash?
Hello?
Sorry.
Hello, can you hear?
Yeah, we can hear
Yes.
you.
Yeah.
Yeah. So yeah, I just I'm Subhashish, as you can see the name. So I am currently working as a product manager for AI in the field of automotive in a company called Jenoptik. And I came to Germany in 2010 to do my masters. I did it in Stuttgart University in the field of digital image processing. And yeah, so I was working with Ross like almost 8 years ago. I
Hmm.
did my master thesis, and but after that, I've not really done a lot. But then I was working more as a developer for algorithm development in image processing and computer vision. During last like almost 8 to 9 years, I worked with like autonomous driving. Then first I worked with also robot navigation. I saw the last meetup where you were discussing about the topics like slam and all that. So that was something I did also in 2012. And so now last 6 7 years, mostly developing some algorithms on the defect detections on metal surfaces, which is like used in quality assurance for production of automotive parts, mostly the engine blocks.
What sensors
Uh,
do you use?
sorry.
Actually, no. This introduction, yeah, but good to have you. It seems like you have done everything.
Not really everything, but I found, I mean, I actually went through all the presentation last time, like around
Mhm.
7 to 8. It was very, very nice. And I really liked how it went through. So it was really, and you guys have also like done a lot. So I wanted
There is
to
a lot
be
that we
part
can
of
learn
it.
from you.
And I love that the way Chandandip was coordinating the whole thing. It was really awesome, very smooth, and I really enjoyed it. So
Thanks a
yeah.
lot, Subhasis, and we are glad to have you, and hope to also see you in the coming meetups.
Yeah, I would try my best. And today I brought also one of my like kind of a junior whom I was kind of guiding for studies at masters here. I'm living. So I
Oh
also
wow,
brought him today to this meeting. He's also with me here. Hi guys.
Oh, that's so nice of you. I'm so sorry
that's so nice. Yeah.
for.
So his name is Faizan. But I mean, I told him to come and join the group. So maybe next week he would. Yeah, yeah, I will join from my laptop tomorrow. But today we are together, so we saw the whole presentation.
All right.
Thanks for presenting your work. It was really interesting, Atmaraj.
Yeah.
I would like to
Thank
show
you,
more. Like,
Atma.
if you can see this video, it'd be nice.
Yeah,
Yeah.
yeah, sure. We
Glad to
definitely
have
gonna
you.
watch it.
Yeah.
So
Okay.
I'm Faizan Kabir, and I'm from India. I did my bachelor's and master's from India, and then I finished last year my master's here in Germany. So I was doing my internship in deep learning, in reinforcement learning, and also my thesis was about this autonomous driving with Continental.
Ah,
And currently, yes, and currently I'm working as a developer engineer regarding artificial intelligence, mostly with
Nice.
deep learning. Yeah.
yeah,
That's
that's
nice.
So
quite interesting. That's
yes,
a
Like
good.
dream job.
That's a like. Yeah, quite a good profile.
yes, thanks. So we are just sitting together and we were looking to your
And
presentations.
Yeah,
And I
that's
really
that's
like
awesome.
this podium, like how you guys have managed and kind of share of knowledge and ideas. It's really good. And I hope it grows with time and it grows bigger and bigger.
Thank you.
you've
Thanks a
done two
lot.
masters, right?
Sorry?
You've done two masters, right?
Yes, yes, I have done two masters.
What subjects are those two in?
So firstly was about power systems, and my thesis was about the smart microgrid. And I have done from Sharda University in Noida, if you know.
Yeah, I know.
And currently I have done about the smart systems, and my thesis was about a regeneration of data set for different camera perspectives for autonomous vehicles.
Oh, okay.
Yeah,
So you're
that's
working with yellow actually.
Yes, yes, I was working with YOLO V5 and V4, and I was like making the data, pre-processing the data, then regenerating the data for different camera perspectives, so that the company doesn't have to make the new data for new vehicles when they are, so they have the already the camera with AI or neural network implemented in it, and they are using that camera for the object detection, land detection, but each time when the perspective of the camera changes, they have to make the new data. So my job is that we if we have the old data and with the labels, and I use that old data and I regenerate the data based on the new camera perspective.
Hmm.
So I was asking Faizan if he can make a presentation sometime about his thesis. Then it would be very helpful for everybody. I think so because there was a lot of concepts which were covered in that thesis.
yeah. I think
Like starting.
that would be really amazing because that's a very interesting topic, and I'm sure we all can learn a lot. Uh,
Yeah, yeah, sure, definitely.
At least some of the concepts like presenting, like showing, like starting from object detection, camera calibration,
yeah,
then about transforming from one
Perspective
perspective to
to
another
other,
one.
and then training the
I
model.
mean, I think the best thing about here is like we have people from different like backgrounds,
Backgrounds.
and then when you share, then you see real life use cases and how which
Yeah.
technology is used in which problem. That really broadens up the thinking. That's the main thing.
And
yeah.
we have
So
both students, researchers, and also professionals in the
Yeah,
industry. That's very cool.
yeah, so I
exactly.
mean, yeah, from my side, I, as I said you, I have like been little bit out of touch from like in this particular field in robotics, because it's been like around 7 8 years, but I can correlate with the things which is discussed. So
Hmm.
of course I can like when Atmaraaj was explaining, I got this question about this point cloud, because something like the similar
Hmm.
like
Hmm.
so kind of correlating it. And yes, it's really great job, and
Yeah, yeah, it's really good.
I think really we would love to contribute as much as possible. That's the
Yes,
best way,
yes,
and it's excellent. I mean, to see so many people doing so many different things.
yes.
Yeah, thanks a lot
So
for
many
the
people.
really nice words. I think we should all thank
Yeah.
Atmaraj for today's presentation and all the efforts
Oh
that
my
he
God.
I would say
did
please
Calm
don't
today.
stop it,
presentation.
even if the number of people are reducing because of their daily schedules or whatever the reason may be, but please keep it going.
Yeah, we definitely will
Thank
be
you.
doing it every single week. So like last time we didn't have a topic, but we still met and we had like a casual networking session. So the idea is
Mhm.
we still at least get to know each other if we do, even if we do not share a topic. Of course, the ideal meetup would be when we discuss a project or something.
Hmm.
Yeah, so feel free to volunteer for the meetups, and as you want to share that particular project of yours, just let me know. There's this meetup volunteer section that you can write your project description into, and then I can allocate it, or just yeah, just message me. I'll guide
Okay,
you how to do that.
absolutely.
All right.
And Sudeep,
Okay.
I just saw like, is there any WhatsApp group regarding this?
No, actually, no.
Oh, okay, okay.
So normally, I don't know how much active you are, Chandandeep, on this, because if I remember, it took couple of days or like a lot of days before it was accepted in the member. So Like normally, how is it working? Like, are you doing it once a week, all the people into this group, or how does it work?
Actually, the thing is that ideally you should be automatically getting approval, because once you give your introduction and just scroll to the top of the introductions post and just click on it, react with this green tick,
Like, yeah.
then you automatically get it. So I don't really have to approve, but sometimes I know it's at the very top and it's not very obvious. So I'm for those who don't get a membership, I just manually do it. But
Ah,
ideally
okay, okay.
you can get access to all the channels on your own, so I don't have to approve
Ah,
or
okay,
anything.
okay. I thought like because I mean I didn't know I did everything, but maybe that clicking thing I don't know if I did it right. So I was like I wrote you a message, then I said something is going, I'm not getting
Hmm.
through. So
There's an icon actually in the introductions
okay, just a second.
channel, like pinned message, and if you click that, you
So
go immediately to
can
on top.
somebody just show quickly, like 2 minutes, just this process because where exactly you have to click? Just can you show it once?
Yeah,
Yes.
I can share the screen.
Yeah.
um, so
Uh,
basically now
I,
you
I
are.
like I would like to add something with okay.
Mhm.
Basically info Subhashish's idea. I thought creating a WhatsApp group would be also nice.
Yeah.
Sometimes things get difficult here at
Hmm.
Discord, and
Yes,
there are
yes.
some
I
problems
was I was
because
also
it's not
actually
user friendly.
Yeah, I was
So for
actually also thinking that at least for announcing that we have meetings today, because not everyone uses Discord very often, so that's
Yeah,
actually a good
exactly.
idea
Yeah.
as well. Hmm.
Yeah.
Yeah, I wasn't sure that people would be interested or not, but yeah, I mean, it doesn't take any effort. I'll make a WhatsApp group if you all say.
Hmm.
Yeah. I mean, it's
If it's related to this, then why not?
yeah.
yeah, definitely.
Yeah.
Okay. Yeah, I
I mean,
mean,
it's at the end also creating a really nice networking at the same time. So people
mhm.
have some questions they can
Yes,
ask.
adding
So
someone would also be very easy.
very easy. Yeah.
We can share the group link and he can join, he or she can join directly.
I think Telegram would be better, by the way.
I mean, Telegram is like I don't know how many are using it,
That,
but that's
that's
the
also
problem.
depends on the users.
Some
Hmm.
people maybe do
That's
not
the
even
thing.
know about it.
Okay, then you can say safe side.
I guess
I
WhatsApp will be
signal.
safest bet.
Now,
I just
That's
signal
true.
to
if you
ensure.
think now the signal is already like riding the waves.
Yeah.
Hmm.
Yeah. After a while, we're going to ask Chandra they make Instagram, whatever, all social media, Reddit, subreddit,
I think WhatsApp would
building
be
culture.
enough, right?
Yeah.
Yeah,
Starting from WhatsApp will be better.
yeah.
Yeah.
WhatsApp
Okay.
will be the best thing, I think.
So yeah, so like
Hi
talking
guys.
about your question.
Guys,
Sorry.
you wanted to scroll, right? I just wanted to add that you can go to the pin tab, the right on top.
So you first write down this
This is the pin tab.
format. Okay.
Yes.
Oh, okay. If you click there, then it's
You can
So
also
here,
go jump.
actually,
Like if you,
on this pin tab, you don't get to go to the pin
you
post directly,
no,
right?
no,
They
you
will
can actually. You can actually click that again and just go
jump.
there,
Okay,
jump.
yeah.
Yeah.
Even
And
even
there,
I didn't use it
yeah, I
before,
found it
but
as well. Was trying to add my friend.
yeah, Discord is like not very obvious to be honest.
Yeah.
okay.
But
And then you click on this 116,
yeah,
this button.
exactly, exactly.
It's like,
So currently, I think we have around 390 to 400 people, but only 116 have
oh,
done this. But I mean, I
it's
think it's
understandable.
important that people introduce themselves to maintain the quality, because sometimes people were spamming as well.
Yes.
So I think this
Yeah, that's
introductions is I think important for getting an approval. Uh, yeah.
No,
So
it
Plus,
feels like,
additionally, it's good
getting
that
into
the introduction
Hogwarts. Like,
system is
oh,
there.
yeah.
Sorry.
maybe after some time you
I
should
am
write like
accepted.
after this write like a cover
That's
letter.
how it
Yeah.
feels. So
Hi guys.
I like this
Guys, I have a
challenge. Hi,
question.
guys. Yes.
yeah.
I have a question.
Yeah.
I just I recently got to know that there is this one course from Trollhättan University. It's a distance learning course related to robotics and automation. The name itself is Robotics and Automation. Uh, I was thinking that because I know a lot of us are doing masters or some or the other type of education related to robotics. So I'll share the link in this chat only.
Can someone please have a look at it and can tell me? I mean, like, is it worth going there?
Okay. Yeah, yeah, maybe you can just share in the chat room and yeah, can have a look and see what it's about.
Also, now
Definitely,
that Akshay
because
is finally connected, he can introduce also.
Yeah.
Yes.
oh yeah,
I
hey
think
hi guys, I'm
before
really sorry.
before you introduce yourself, let's finish with the presentation so I can share the video which should be working now. Right?
Yes.
Let's finish with it so that we can have the discussion
Hmm.
more casually, right? All right.
Yes.
So
Can we
okay.
try with mine? Then I can pause as well.
Do
Because if you
we?
play it, yeah, let's try it once with my Discord. I'll try to share the screen
Okay. All right. Yep.
because in the Google, if you play it from through Google, it's downsampled and it's really not clear.
No,
We
no.
can just
I
give
think
another try.
it's downloaded, so I'll actually share
Ah,
from
okay.
local one. But
Okay.
let me know where you want to pause for some
Okay. Yeah.
explanation and stuff.
Yeah.
I hope this works. Yep, seems good.
Okay. Yeah. With simulation, it didn't work as expected. I'll prepare better next time, guys. I'm so sorry.
No, no. I think
But
it was already very good preparation, and with the
it
demonstrations and stuff, I think it was already very good.
we could say like this, it can't get worse. So I've set the lower boundary for
No, no,
myself.
no, no,
It's-
not at all. I think it was
and
good, guys. What do you think? I think for me, at least, it was really good presentation. And normally we also don't share simulations. I mean, at least I didn't share simulation
Mhm,
when I did. So I mean, I definitely learned a lot.
mhm.
Yeah, the
Thank you.
simulation was pretty cool to see. I would love to
Yeah,
see more
Atmaraaj, it was really
live
nice.
simulations of it.
Thank you, guys. Oh, now I feel so praised and loved.
Yeah, thanks,
The next
Atmaraj.
iteration, I'll make sure it's better and prepare better. Thank you guys for being awesome audience and questions.
Atmaraaj, you're working right now, or you are studying at university?
So I'm doing my master's thesis now at
Okay,
another at Neura Robotics.
okay,
We actually, I'll post a job position. The company is looking for uh, talent. They have many positions open, but
okay,
you just reminded me to post it there. But on my master's thesis also on a similar topic. So we have a running solution of grasping AI assisted grasping that's working pretty stable there in my company, but I couldn't really share it because it's
Yeah.
yeah.
all
Hmm.
secret.
So
Um,
you are working your master thesis together with with Neuro Robotics, right?
yes,
Okay, Neuro Robotics is the company, and you're doing it at Reutlingen University.
yes.
Okay, so you plan to join here afterwards.
Um, I have been offered the chance,
Okay,
definitely,
very
but
nice.
I'm from Malaysia, by the way.
Oh, okay,
I want to go back to my country. Like I have been studying here for the past 6 years,
6 years.
but
Okay,
I'm
okay.
I'm also under scholarship and all that. So there is this bondage with the government that I promise that I will come back.
Okay. So
That's all.
6 years means it's like a German diploma, or is it like, because masters normally it's 3 years, right?
Yeah, I did my bachelor degrees here as well.
Okay, fine. Yeah, it's like diploma, right? Together.
Yeah, together.
Yeah.
So,
Yeah.
Atmaraj,
Yes.
this was your introduction, right? Also, guys, I think I have to mention it again that I'll be sharing the video on YouTube, and since we are doing our introductions, and some of us might not be okay with getting it shared online, so you can just let me know, and I'll specifically cut the introduction portion from the video. Just yeah, write to me
Hmm.
after this. Yeah.
Yes.
So that was Atmaraj. I think we are all very familiar with him already now. Uh, I think Akshay could introduce yourself now. I hope your internet is fine now, or if not Akshay, then let's start with Mudit.
Give me more 5 minutes, I'll be there.
Okay, okay, sure. So meanwhile, Mudit, maybe you can introduce yourself.
Okay. So, hi guys, I'm Odit. Uh, I'm a master's student at RWTH Aachen in Germany, and yeah, I'm right now doing my internship at BMW, and soon I'm going to start my master thesis as well. I have been working in artificial intelligence, especially the deep learning and computer vision for like past 2 years, and yeah, I'm gonna start my thesis also in the same field as well. So yeah.
Welcome, Mudit. Welcome again. And yeah, let's hear from NAJ0.
No, I just wanted to mention, like we did discussion on computer vision concepts in general, and we had some experts in a group. When was this? Meetup 6 or Meetup
Uh,
5?
I don't remember the number. I think it
Yeah.
was fifth. I think we did two meetups on computer vision. I think one I didn't record properly. The other one is
Hmm.
already on YouTube. I can, yeah, share the link. And probably I think we plan to do more of computer vision meetups as well later, because we had a
Hmm.
really good response. And there are like already so many topics in computer vision that we can go on for multiple meetings and probably still cover only
Yeah.
some portion of it, right?
Maybe
So
Najma will be inspired by it and
yeah.
also learn something and eventually also share something. Nice. Hmm.
Okay, awesome. Yeah. Good to see you, and hopefully see you also in the coming meetings. And I'll share the computer vision video with you after this meetup. So moving to Srinivas, how are you doing?
Hey man, I've been introduced, but yeah, I am a master student in Passau, Germany, and my field is related to control systems theory as of now, and more towards simultaneous localization and mapping. But I'm not doing anything related to computer vision or anything. I'm as of now only working with 2D occupancy grid maps based on lidar data. I haven't completely gotten there, but yes, that's what I'm working on right now. I'm currently trying to start my thesis for particle filters and such non-linear state estimations for anything, basically.
Yeah. Welcome
Yeah.
again. How's your thesis
Yeah.
progressing?
Uh, I'm having some troubles here or there while using particle filters. And if so, Sai, right? Like he joined earlier, but we couldn't. Like he left sometime, I think, for whatever reason. So he and I, we're working. We're trying to. We discussed this during the day when we did ad hoc topics. I
Yeah.
think that day we chose particle filters and occupancy grid maps and all of that.
Hmm, 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 hmm.
So we're trying to work together on raw Black-Levelized particle filters, and then probably, hopefully soon, we will be able to do a paper presentation or a project presentation.
Oh wow.
So this University of Bonn and University of Freiburg, there's this guy called Cyril Starkness who
Yeah.
publishes great videos
Hmm,
for
hmm,
Slam,
hmm. Yeah, I have seen those
and he
videos.
has a homework section type for his class related to particle filters.
Hmm.
So we're hoping to get working on it, but I think we're both a little bit behind schedule. But yeah, we'll soon get to it.
Yeah. Yeah, interesting that you mentioned the that YouTube channel by Professor Cyril Staknes, and I think that's also specific to computer vision. So Najma, right? I think that would also be interesting to you. Uh, it also has like 5 minute explanations of complex topics in a very simple way. I also liked the way of explanation.
And more importantly, he explains in not the 5 minute ones, but the other ones. He explains the math really well. Like
Yeah, yeah.
you start with the basics, and it's an entire 6 month course, but it's well worth it to go through the entire course.
The homework and stuff, is it on the official website? Where is it? Because I didn't find it.
Um, so this homework is only available for the SLAM 13 14 year course,
Mm-hmm.
and in Uni Freiburg's official course webpage. I'll put the link in the chat room maybe.
Hmm.
uh, there's all these PDF documents available for the slides, the video links, and then the homeworks also. He additionally also posts like additional material or papers that you should go and read. That's
Right.
what we are trying to do first. There's a paper called Improved Proposals for Raw Black Light Particle
I can hear
Filters.
him.
Sorry, what?
Uh,
Hello.
We lost you for a while. Sorry.
Okay. From where?
At PDF documents, and then
Oh, since then. Yeah, so he puts PDF documents related to the slides that he uploaded. Then he puts the video links and the homework documents. I think he doesn't. I mean, you can't obviously verify if you're right in the homework documents or not.
yeah.
Yeah.
Yeah, but that's interesting because I didn't know that we had these homework assignments and stuff. I saw some of the lectures and they're really well explained. So when
Yeah.
I was giving my exams, I definitely referred lots of content from there. So yeah.
He also has one modern C++. If someone's interested, that's a really good course. He doesn't teach it. Some other professor named Igor teaches it.
Mm-hmm.
But it's one of the best explanations that I've seen. You need some basic C++ knowledge, and he goes through fast, but it's really good. He does it with modern C++ and image computer vision, something related to that.
Okay, interesting. Yeah, if you can share the link, I think that would be really helpful.
Sure thing, sure thing. I'll put the links for both the computer vision, the C++ course, and the Freiburg course webpage.
Okay,
Also on
awesome.
University Freiburg's webpage, there's another series of videos by Professor Burgard on probabilistic robotics.
Yeah, that's what introduction to mobile robotics, right?
No, I think that's a different thing. Uh, it's
Oh,
not
okay.
by Professor Cyril Starkness.
Because
It's
this
by
SLAM course is based on probabilistic robotics. I thought that's the only one that's based on probabilistic,
oh,
the
okay,
book. But I'm
okay,
not
cool.
sure. Okay, if you can put the link, that would be great as well.
Yeah, cool. I'll do
Okay,
that.
Yeah.
yeah, interesting. Okay, let's move to F. Kabir. I think this is the first time you're joining. Could you introduce yourself? I'm not sure if he can hear us. Uh, yeah, I think Akshay is left. Yeah, you can also introduce yourself if you're now comfortable.
Yeah, sorry. Actually, the moment meetup started, I boarded into the train, so I was all on and off. Hello, am
Yeah,
I?
sure, sure, sure. No worries.
Yeah. So hi guys, I'm Akshay. I'm another enthusiast for robotics. Recently joined this group, and yeah, I really love computer vision. That's where my master's is, and currently I'm in Sweden. As a work, I do data analysis for autonomous systems. Right. So right now I'm working for uh, what is their name? Volvo, and yeah, that's all. And for resources, I heard a lot of you guys telling information related to computer vision, so I'd like to point out one person, Dr. Mubarak Shah. So he on YouTube you can find his lecture series. They are, I'll say, slow, boring, but he actually teaches a lot of topics in a very nice possible way, so you can go through them also.
Another interesting lecture series. So yeah, I guess you could also share your link in the chat room, so we all can also benefit from this thing. Dr. Mubarak Shah, right?
Yes, Dr. Mubarak Shah.
Hmm.
Because a lot of because in computer vision you have a lot of basic things. Because if you'll see, almost all the new things that are coming in are built on top of these things. It can be as simple as uh, this optical flow, or
Hmm.
Harris corner detections, all these things. But these are the very basic ideas where the computer vision started, and he explains those topics in a very simple possible way.
Hmm, hmm, hmm. Interesting. Yeah. Yeah. Thanks for the recommendation, and also thanks for joining today. I think we also
Thank
have
you.
now Krish.
Yeah, hi guys.
Hi, could you
Hello.
introduce yourself briefly? I think
Mm,
everyone knows you
it's,
So
by
it's,
now
mysterious.
already, the youngest member of the group.
yeah, there is nothing much to tell about.
Youngest and the smartest kid in the group.
Yeah.
The up and coming one.
The next upcoming big thing.
Yeah, you could say so. So
Also, maybe
yeah, so
sleepiest at the time.
uh-huh. Sorry.
Sleepiest because it's late now, right? Back home.
Yeah,
Ha
it's
ha. So
also
it's
quite
late
late
in
there.
India. Yeah. Yeah, I think so. Actually, what I was called for a thing. So if some of you guys know about this, that I'm involved in a competition, and we were given the final task this week, and I had a viva today itself in the morning. So that is available on YouTube. You guys can check out. So our we had selected the first slot in the morning itself. We had talked about that a lot, and there I guess the viva went really good, and it was actually the competition was around simulating robots in VBots. So VBots is just like ROS in some ways, where we worked on simulations around the Epoch robot by GC Tronic. If you want, you can check that out. And we were given uh, like zip files online where we had to extract them, and then there were maps, different maps like wall following, line following, or even image processing. Certain maps were there where we had to complete the challenges in 1 week. Sometimes it got extended to 2 weeks for some tasks because the task complexity was too the task was too hard to solve for some teams.
Hmm.
So today we had a viva, and then tomorrow we have the results. So let's see what we stand. Or I mean, there were a total of 71 teams who participated, and only 16 could make it through the finals
Oh
that were
wow.
today. And all the 16 teams had a viva session of around 15 minutes.
Hmm.
So there we the video was played which we had shown for our demonstration, and there was a funny part to it. I mean, we attached a 1 minute meme video which we made. So that was just for fun, which we could include inside the video itself. I mean, there were instructions to that, and then there was a vibe around that. So I guess yeah, we did good.
That's awesome.
Congratulations, dude. That awesome stuff you're
Yeah,
doing.
that's already great, right? I mean, in the top 16 out of 71 teams.
Yeah. And
So,
we were, and the Viva was also like very grilling. I mean, means the teams that were evaluated after me, the questions were basically all around the same background, but different situations. So one particular situation that we were given to was that while the bot was line following, so we were using the camera to follow the line, not the popular way of following the line by the IR sensor array.
hmm.
So
Mm-hmm.
we were actually following the line using the camera. We were actually calculating. We were first converting the colored image into a grayscale image. Then we were using thresholding. So we were using the thresh binary technique, and
Hmm.
then we were converting the black line into white color and the white space around it in black, and then we were using the concept of image movements to find the centroid of that particular line, and then through that through that error value we were just inputting that into the p controller or a proportional controller. We were not made yeah, I mean the teams were actually very young, So they some teams were even 3 4 younger than me. So the IND part was not introduced to them, although it has been introduced it in at school level for my team, because we all were in 11th grade or third year of high school. So we were introduced to calculus. I mean, we could have done that, but yeah, and using that, we followed the line, and there was one question on proximity sensors, which we had prepared the night before that, and the same question came. I mean, how do proximity sensors actually work? So we were
That's good.
glad that a question that we had prepared had come. And
Nice.
then, before joining this session, I was made to join this Google Meet, where someone from the organizing committee WhatsApped me saying that, can you come for like 10 15 minutes? There is something going on with our code. Then we came in, then I went there, and then they told me to rerun the code in my computer because they were having some issues with their computer. And luckily the code survived. I mean, the code managed to complete the run, and then I got seriously shocked. Then I shared my files to them. Then the code was compared, the backend code, the backend code was compared, so so that they were making sure that I had not changed anything in their backend code that was not supposed to. So all these things
Yeah.
just happened before this session, so I literally got scared. And after 1 hour, I managed to come into this session.
Okay.
Nice.
Yeah,
It's an
nice. That's
eventful week.
really good. Yeah, and wish you all the best for the results. Just let us know how it goes.
Mm. Yeah,
It's nice
definitely.
how natural your learning is, because everything that you mentioned, this thresholding and stuff, like you learn in
Mm.
the university in the computer vision
Yeah, exactly, right?
core. Exactly. So, but you came with it, I guess, with some Googling and some discussion. I don't know. How did you come to this idea?
Yeah. uh, so that idea, actually they had shared some kind of documentation with us. So there was a
Mm-hmm.
website that was encrypted. I mean, we had to give our login ID and password to go through that website, and
Mm-hmm.
then there we had to log in, and then there were sections. There was a section where you were made aware of the problem statement. So there were like 5 6 sections of the task, like they will make you aware of what is the task about. And there was a separate learn section where you had topics related to basics of Python programming, maybe image processing, maybe controllers like bang controller or a proportional controller, or how to design controllers for wall following, line following. And even you had a section for sensors,
Hmm.
like the proximity sensor. There was a section for camera
So
and
the resources were all
motors.
there, and you
Yeah,
guys
the
were
resources
using
were,
it.
yeah,
Hmm.
yeah, but
Nice.
what was special with us, that our algorithm to follow the line was quite different and simple, if I were
Mm-hmm.
to put it in words, because their original approach was to first crop the image, and then using that cropped image, you find contour values, and then you compare the contour values with some disturbances that might come during the run, like shadows or some kind of some kind of scattering going around. And then you had to compare the area, I mean the largest area. You had to compare that and use that to follow the line. So the line will have the most amount of area in between those contours, and then using that we had to make the code. But later we realized, after even after changing the kp and the average velocity values so many times, it was working just like a bang controller. So it was
Mm-hmm.
going left right left right left right
Hmm.
around the line. So I gave up on that method, and then I actually reused the method which had originally came even before the documentation was given to us for that task. The world was given a day before to test out our thinking skills, because they give the documentation a day later, because they want the students to first try out on their own if they can, if they have the
Yeah.
time. And then I tried that out and it worked. and it was quite simple. So even in hard right 90-degree turns, which we were very quite sure of that it would not work, somehow my other teammates adjusted the KP and V values in such a way that it was working. So
Yeah.
we were quite happy with that.
Yeah, the
So
best
then we
solutions
submitted that.
are actually the simplest ones, right? The ones where you don't
Hmm.
over engineer stuff.
Right. And there was one team that was, if you want, there was a team named Team 66. I mean, I don't remember the team name, but their code was like quite large. I mean, ours was less than 300 lines because we had to make the code modular, and I had defined 12 functions. I mean, with the others in my team, we had defined 12 functions. And then the code in the while loop was around 15, 20, 10, 15, roughly 10, 15 lines. And I just called the functions that were initialized above and in the while loop. So, but when looked into their code, I mean, they had literally blackened out their code, although it was not allowed to do so because you had to show your code somehow because it was an instruction. But they blackened, I mean, they shadowed it because other teams could not see that. But the thing is, they wrote I around 400 lines of code. They had not done the modularity enough, but their code was robust. I mean, we were told of certain test cases that the bot will go through. Like there was a transition tunnel in between the wall falling and the line falling. So that transition tunnel had a color. So using that color, we had to switch from the wall falling code to the line falling code because it was not time based. I mean, you can't switch between the codes with respect to the time. So you needed some kind of uh, some kind of physical thing to change the code. So we changed the color. So even it was given to us initially red, but we made the code robust in such a way that it would work even in a green tunnel or even in a blue tunnel, and then it would pass through any of those red, green, or blue tunnels.
Okay.
Then there were certain test cases where the turning or the radius of the turns will be made quite smaller than that was given to us earlier, or the distance between the two hard turns that would be reduced to about half. I mean, we tried making our own arena, but it wasn't working in that. I mean, the arena was perfect, but we could not make the code robust according to our code. But our code was simpler to understand in a layman's language,
Yeah.
as I would say,
And it worked
and
at the
even we
end,
had to
so.
write and even we had to write doc strings for it. So like doc strings, you had to explain
That's good
each function
practice.
what it is doing. Yeah, I mean those had marks, so we had to do. I mean code had 100 marks, so 20 marks were to robustness, 30 marks were to documentation, 20 marks were to approach, and another 30 was another 30 was about the modularity and how have you named the variables and such.
Yeah.
So there were total of 100 marks, and there was a time score where the best score, your time will be divided by the best time, and that will be multiplied into 50. So we were thinking that ours was the best time, but we were wrong. It was 4 seconds longer. So our code score, which we think is around 47 out of 50 in that, and I think it will fail one robustness case if it, I mean, the instructors are telling that the code might not be even you ran through some, I mean, they will only run the code through some test cases only, not all the test cases, so it will
Yeah.
be random. Yeah, I
That's
mean,
awesome.
they told us like that, and we believed them, and then we all left it to probability that it would not go through the other case, which I am telling that it would fail. And then let's see what happens tomorrow because
Yeah,
they called me
that's what makes it fun.
11 in the night. Yeah, and they called me 11 in the night, and they are asking me to rerun the code in my computer.
Yeah, it always
And I
happens
mean, I
in
got
in
scared.
the competitions,
Yeah.
right? There's unexpected things going on. Yeah, so
Hmm.
actually now I think it's I have to officially end the meeting
Hmm.
because it's
Hmm.
2 hours. But I think F Kabir hasn't introduced himself, so maybe I'm not sure if he can turn on his mic. If F Kabir, can you introduce yourself?
Yeah, sure, Chanandip. I'm the same guy who was sitting with Info Subhasis.
Ah, okay, okay. What's your first name? I forgot.
It's Faizan Kabir,
Faizan, yeah,
the
okay.
complete. Yes, yes.
Yeah, so you joined separately now, huh?
Yes, yes, yes. So while we were talking, I made a new account and then he sent me the link. I joined
Very
this.
productive.
Yes. Thank you.
Yeah.
So,
So
do I have to introduce again
I
or?
think you introduced yourself already, so that's fine.
Okay,
So
okay,
yeah, I
thank you.
think unfortunately I have to end the meeting officially, but you can stay in the room and continue discussing as well. Yeah, it's totally fine, or you can also form separate groups or talk to one or two people individually if you want to. But yeah, I would actually have to leave now.
Me too.
So before that, I have to actually thank Atmaraj for the really interesting presentation and simulation demonstration that he did today, and all the efforts that he did, and also everyone else who participated today. And yeah, we'll continue doing this in the next weeks as well. So for the next week, uh, if anyone wants to volunteer, just let me know. I think yeah, some of the people already, yeah, told that they might be interested, but just write in the Meetup volunteer channel. It's in the events, it's in the events section, so you can find it, or if you have trouble finding it, just let me know. And if we have a volunteer for the next week, it would be really great. Otherwise, I have to think what else we can discuss. Otherwise, we could just do like, yeah, the computer vision topics thing that we did one time.
Everyone can bring out their projects, master projects, and discuss
Yeah,
them.
yeah, I
This is
mean,
like
that
we
would
have.
be not
Yeah.
requiring that much efforts as well.
Yeah.
So that's actually a good idea.
Thank you for being a great audience, and thank you, Chanandeep, for being a great host and also
Thank you.
helping, assisting whenever things
Thank
were on fire, which was throughout. So, okay, thank you.
Okay, thanks a lot.
Very good. See you guys.
All right, see you guys. You can continue
Thank you.
discussing, but I would have to leave actually now. Uh,
I also do. Bye
okay.
bye, guys. Nice
Yeah.
meeting you.
Bye. See you next time.
Yeah.
Everyone.
Mm.
See you, Chandeep.
Make
See you
sure
next
to
time.
yeah, write to me if you want to volunteer.
Okay.
Yeah, sure. Thanks.
All right.
Okay. Yeah. Have a
Bye
good
bye,
evening or good
You
night.
too.
guys.
Yeah.
Yeah.
See you next week. Good luck,
See you
Krish.
next week.
Bye
Good.
bye.
Bye.
See you later, guys.
Next week. Bye bye.